Hi everyone, so this is part 2 of my integration by substitution masterclass. If you are unfamiliar with how integration by substitution works, I would recommend that you look at my previous video, which is titled part 1. I'll be following the same methods that I used in part 1 and just applying these to some more difficult integrals. These tend to be around 6 to 7 marks on average. I will be going through some much harder integration by substitution questions in part 3. Okay, so we're just building up. Let's start with this one then. So we have the integral of 1 over, then we have 1 plus 2 tan x all squared multiplied by cos x in the denominator. Okay, so the first step that we used in part 1, if you remember, is we differentiate both sides of this. I just write du on the left, differentiate this expression, remembering that tan x goes to sec squared x, and so we get 2 sec squared x and then dx on the end. Then we want to rearrange for dx, which then gives us du over 2 sec squared x. And don't forget that sec x is 1 over cos x, which you can remember with the third letter. So that would mean then if you have 1 over sec x, that's cos x. So if I just attach a square there and a square there, you can see that this sec squared x can also be written as cos squared x. And so I'll write this as cos squared x du over 2. So there, straight away, I have something for dx. And then remember, I have this substitution for u, and so that gives me this part here. Now the only other thing that I'm going to need is to sort out this cos squared x part here in the denominator. Remember what I said to you in part 1 is you should always check dx to see if there's anything that might cancel out. So you should notice that there's a cos squared x here in the numerator. So when I substitute this in place of dx, you should see that the cos squared x would be at the numerator, which will then cancel these two terms. So this has also been sorted out. So now I'm just going to substitute since I'm happy with everything. So remember, u is 1 plus 2 tan x, so this is just going to be u squared. And then we have cos squared x there at the bottom still. We have the 1 at the top. And subbing in for dx, we have cos squared x du over 2. Cos squared x will cancel here, which is nice. And the 2 at the denominator I can pull out as 1/2 since it's a constant, and all that's going to leave me with is 1 over u squared du. We don't like to integrate in this form, remember, this is first year, so we will turn that to have a negative power as follows. Next we perform the integration. Simple first year integral, or square bracket now. Increase the power by 1 and divide by the new power. Gives us u to the minus 1 over minus 1. Don't forget the plus c, because there's no limits. You will lose a mark if you forget. That minus 1 I'm going to pull out to the front, so it's minus 1/2, and then remember, if we have a negative 1 power, I can write that as 1 over u. And then don't forget to also put u back in, which was 1 plus 2 tan x. So this is going to give us there we go, that will be the final answer. Cool. Let's move on to the next one. So here's another one. Obviously this time we have limits, as you can see. Those will need to be changed in terms of u. And we've also been asked to write the answer in this form with a log natural. The substitution given for this question is u equals x to the power of 4 plus 2. So let's firstly differentiate. So we get du equals 4x to the power of 3 dx. Rearranging that for dx gives us dx equals du over 4x cubed. So let's write what we also have sorted out. So we've sorted out the x to the power of 4 plus 2 with the u here. And we have sorted out the dx since we have the rearrangement there. Now let's think about x to the power of 7. So what I'm noticing is we actually have x to the power of 3 here in dx. So if you consider what's going on in the numerator, x to the power of 7, when we sub in for dx, we are going to have effectively x to the power of 3 in the denominator like that. So that will turn into a power of 4. Now, that means that we'll still have x to the power of 4 within this integral once we've subbed everything in. So we still need a rearrangement in terms of u for x to the power of 4. What you should see is x to the power of 4 is actually in the u expression. So I can simply just rearrange for x to the power of 4. So if I take 2 away from both sides, that gives x to the power of 4 is u minus 2. Just rub that out since I'm not really bothered about that anymore. And that means I'm happy with this because I have something that I can substitute for that. Last thing to think about is the limits. Please don't forget to change your limits. So at the minute we've got limits in x which are 1 and 0, and we need to turn these into u limits. And for that we just use the expression here. So if we substitute our x value, so starting with 1, we have 1 to the power of 4 add 2, which gives us 3. And then with the 0 to the power of anything is 0, add 2 gives us 2. So these are our new limits, 3 and 2. So let's now substitute. Okay, so the limit's going to change first into 3 and 2. Then we have x to the power of 7 at the top, which I'll just keep for now. At the bottom we have, remember, u is going to be substituted in this bracket, so that's u squared. And then dx. So like we were saying earlier, we've got the x to the power of 3 in the denominator here, and we have x to the power of 7 in the numerator. Let's do a bit of simplifying. I'm also noticing the 4 in the denominator here, so I can pull that out as 1/4 at the front. X to the power of 7 divided by x to the power of 3 gives us x to the power of 4 over u squared, and then we have du at the end. Remember, x to the power of 4 here is actually u minus 2. So that's u minus 2 over u squared du. And let me do a little bit more to it. So I can still simplify a bit more, because u divided by u squared gives us 1 over u. Now you need it like that, because remember, 1 over u or 1 over x will go to log natural u or log natural x, and they did say we want a log natural there. Okay, so now the other bit, we have minus 2 divided by u squared, so that'd be minus 2u to the power of minus 2 du. Let's go ahead and do some integration. So we should get ln u for this one. And then here what we need to do is raise the power by 1 and divide by the new power, which will give us like that. Now notice in minus sign at the top, minus sign at the bottom, which will cancel. 2 divided by 1 is just 2. So I'll just simplify this further to this. Because remember, u to the minus 1 is 1 over u. This just gives you 2, so it's 2 over u. Right, final bit of substituting now. So we have the 3 going in first, so that's ln 3. And then the 3 goes in here, so that's 2/3. Now we put the 2 in, so we get ln 2 plus 2 over 2. Let's just go over here. So we have 1/4 at the front. We have ln 3, remember here. Then we've got take away ln 2. Remember, if you take away logs, you'll end up with 3 over 2. Like that. And then we have a 2/3 here, take away, then 2 divided by 2 is basically 1, so that's 2/3 take away 1, which will give us minus 1/3. Okay, the only thing I'm then going to do is just times everything by the quarter at the front. So we get 1/4 ln 3 over 2, and then times in the 4 and the 3 gives us minus 1/12. So this is your final answer. They did say they wanted it in the form P ln Q. So what you should notice is that is your P, that is your Q, and that is your R. So P, Q, R. There we go. Right, this one, again we've got some limits. Let's go ahead. So the first thing I'm going to do is just change this so it's x to the power of 1/2, because we don't like to differentiate with square roots. So differentiating both sides giving us du. Differentiating this gives us 1/2 x to the minus 1/2, and then dx on the end. Rearrange for dx gives us dx is du over 1/2 x to the minus 1/2. If you divide by a half, you can put that as a 2 in the numerator. So that gives us 2 du over x to the minus 1/2, or it's the same as 2x to the half du. What you should then remember is that x to the half is just u. So that means this is just 2u du, which is how we would like it to be, because remember, it wants to be in terms of u. Great. So I don't really need all of this working out now. All I really wanted was to get dx. So I'm just going to write that here, which will save us some space, clear ahead a little bit, so we don't need any of this anymore. Great. So if you think u being x power of half, which is square root x, that's sorted that one out there. Then how would I sort out x? Well, if I basically square both sides of this equation, it's going to lead to u squared equal to x. So I have a substitution there for x. Remember, dx is over here, so I have dx as well. Last thing to worry about is the limits. So to get u, as it says here, all we do is you square root x. So the square root of 4 being 2, and the square root of 1 being 1. So these are our limits. So this integral is just going to change into the integral from 2 to 1. X in the denominator here is going to be u squared. And the square root of x there just being u. And then don't forget dx, we have its substitution there, which will be 2u du. Great. I can actually rub this out now because I've already put those limits on. So there we go. Let's do a bit more simplifying. So if you think, I'm going to pull this 2 out at the front, then all I have is u over u squared plus u du. This step I'm going to do very carefully because it can confuse some people. I'm going to factorise out u from the bottom, and you should notice the u's here cancel, which is going to lead to 1 over u plus 1 du. Okay, so a lot of people get a bit tricked out of how to integrate this. This will just integrate into a log natural. If you just had 1 over u, it would just go to ln u. If you have u plus 1 in the denominator here, that would just go to ln u plus 1. And you'll have the limits of 2 and 1 like that. So that's going to be 2. We have ln, then don't forget we've got u add 1 in here. So if u is 2, that would be 2 add 1. So that's ln 3. And then this time put the 1 in. 1 add 1 is 2, so that's ln 2. When you subtract log naturals, it turns into a fraction, so we'll get ln 3 over 2, and this 2 will still be at the front. You can also move that 2 to be a power, i.e. squared, so this will go to ln 3 over 2 squared, which is ln 9 over 4. Any of these answers here should be fine. I'm going to stick with that. Moving on to the next one. Okay, so we've got this one here. We want it in this particular form that they've suggested. When you see these forms here, what I usually notice is that it's best not to put numbers into the calculator when you're evaluating a definite integral. You're better off to do it algebraically, especially if they use the word exact. A lot of calculators will just turn them into decimals rather than giving exact values. If you work it through algebraically, you should get yourself an exact value. So I'll work through this one very carefully. Okay, start with differentiating. du is going to be minus 2x times dx. And rearranging for dx gives us dx is du over minus 2x. Straight away that sorted that one out, and this sorts that out. Okay, now looking at the top bit, need to worry about that. If I have an x at the bottom, that's going to take one of the powers off of this, so that will turn into a power of 2 if you like. So then we need to think about what we can do about x squared. Now I'm seeing an x squared there, so I'm just going to rearrange that for x squared. So if I take x squared to the left and then bring u to the right, that's going to give us that x squared is 6 take away u. So that means I'm happy about this, and I'm happy about that. I'm happy about everything apart from the limits, don't forget. So there's 4 things to remember if it's definite. You've got to do the limits as well. So in terms of x, we have 2 and 1. This is our substitution for u. So to get u, I do 6 take away x squared. So that will be 6 take away 2 squared. 2 squared is 4, so that will be 2, so the same. Then we've got 6 take away, using the 1 now, so 6 take away 1 squared, or 6 take away 1 gives us 5. Now you might be wondering, well, the top limit was 2 and the bottom limit was 1, so the top limit was bigger than the bottom limit. Now it's swapped round, so it's the other way. That's absolutely fine when you do use substitution. It's not a problem at all. Sometimes you can find that the top limit is lower. Make sure you stay consistent. The top limit still needs to be a 2 and the bottom limit is now a 5. If that confuses you, I will talk about that in a bit more depth in a minute. Let me firstly set up my integral. So let's substitute now. So it's no longer 2 and 1 anymore. It's going to be 2 and 5. We have x cubed at the top. At the bottom, remember u is 6 minus x squared. So this is going to be u to the power of 1/2. And dx is at the end, which we will substitute in du over minus 2x. Okay. First thing I'm going to do is I'm going to take that 2 out as minus 1/2. So I'm taking the minus 2 out, I should say. I'll take the minus sign out to the front, and I'll also take out the 2 in the denominator. What's that going to leave us with? Well, the x will cancel and just give us x squared there. Then we still have u to the half at the bottom, and then we have du. Remembering that we also had a rearrangement for x squared here. So if I substitute that in, that gives us 6 minus u at the top over u to the half du. Still going to do a bit more simplifying. So looking at this, if I do 6 divided by u to the half, that will give me 6u to the minus 1/2. Then I've got minus u here divided by u to the half. That's going to give me minus u to the half, because there's a power of 1 there. Then what we can do is we can substitute in the numbers. What you also can do, if you wish, is you can put this -1/2 through that. I'm not personally going to, I'm just going to leave it there. So, this should be done very carefully, this part. Okay, so remember this is a first year integral. We just raise the power by 1 and divide by the new power. So if I raise the power by 1, it will become 1/2. If I divide by 1/2, it's the same as times in by 2. So I'll write 12 there. This one, we have going to 3/2 if I add 1. And then if I divide by 3/2, that will become 2/3. But I also have this negative sign, so that will be minus 2/3, like that. So now I can start substituting in the numbers, so starting with the 2, so I get 12, and then effectively I can write that as √2, right? I'm going to stick with this now because notice they're using roots here. Okay, and then let's put the other one in. So we have minus 2/3, and then this time we've actually got √2 cubed, which we'll sort out in a minute. Let's do the other bit. So then starting again, but just with a 5. So we've got 12 √5, and then minus 2/3. This time we have √5 going in there, but cubed. Okay, like I said, be very, very careful. Okay, so what I'm then going to do is just make a note of what √2 cubed is. So if you think, if I was to do √2 times √2, that just gives me 2. And then if I just times by another √2, that gives me 2 √2. And then √5, if I follow the same method, would just give me 5 √5. Okay, so I'm going to have a go at putting those in. So we have 12 √2, take away 2/3, and this is going to go to 2 √2 now. Then we've got 12 √5, take away 2/3 of, this time going to 5 √5. Okay. So this is where we're currently up to here. What I'm going to do is just rub some stuff out because we don't want all this overwhelming stuff going on. We've sorted that out now. That's sorted out. This is an earlier step that we don't need anymore. Lovely. Let's clean it up a little bit. So let's carry on here. So we have minus 1/2. Let's multiply this out. So 2 times 2 gives us 4. That's 12 √2. Take away 4/3 √2. Then we have 12 √5 for this one. 2 times 5 being 10, so minus 10/3 √5. I can rub this step out. Should have went. Oh my god. There we go. Don't know what happened there. So now what we're going to do, I'm going to do this really carefully. Not that I have to, just doing it because I want to make sure people fully understand what's going on. So we basically need to make both the denominators a 3 now. So if you imagine, I'd need to make this 12 into 36 over 3. Writing every step fully so you can see exactly what I'm doing. This one wants the denominator 3 as well. So that means the 12 needs to now be 36 over 3. Now I can do the subtraction since the denominator is now the same. 36 take away 4 is 32. So that gives me 32 over 3 root 2. And then 36 take away 10 gives me 26 over 3 root 5. So we're getting there bit by bit. Right. Next thing to do is to multiply out this minus 1/2 through all of this. I will do that in 2 steps just to make sure that everyone understands. So if I firstly just put the minus sign through everything, that's going to change the order. So the one that's negative here will become positive. So that means the minus 26 over 3 becomes positive. And the positive one is now negative. Brilliant. Last step to do is to just halve what we have. So let's just halve the numerators. So that's be 13 there. 13 over 3 root 5. And then halving 32 here gives us 16. And that will be the final answer. If you look at the form, p root 5 plus q root 2, we have p root 5 plus q root 2, defining p as being 13 over 3, and q here actually being minus 16 over 3. Okay? So there we go. This is going to be the last one I do today. So let's have a go at this one. This one, I picked this one because it's a little bit different, and I think it's a really good one to have a go at, especially if you're thinking about doing part 3 with me and doing the harder integration by substitutions. This would be a great sort of bridging question between those medium and hard ones. So I remember when I did my A-level maths, this was actually in my A-level maths exam paper. I think it was year 2015. So this is from the old spec. And this one I think got me stumped that year. So let me go through that in full now. So differentiating du. This is going to go to 4 and then dx. Rearrange for dx, gives us dx equals du over 4. So there we have dx sorted. U is 4x minus 1, so that sorts that bit. Now I'm looking over here and I'm thinking, does that get sorted out with anything? I'm looking at my dx expression. I only have a 4 in the denominator. So unfortunately, it's not going to cancel. So I still need to sort that bit out. That's when you go to your u expression, remember. What I would firstly do is notice there's 2x there, and I can get firstly 4x from this, which would be u plus 1. Then I want to get the 2x, so I'm building it up. that would be u plus 1 over 2. And then I need to get 5 minus 2x. So I can just write 5 first and then take away what we said 2x was. Like that. Now, I don't like how that looks. I'd rather this be one thing. So let's combine it so it's one fraction. The way we'd do that is write 5 as being 10 over 2. Meaning the same denominator now. I'm actually going to put a bracket there. So that's 10. Take away u and then take away 1 over 2. 10 take away 1 is 9, so this is 9 take away u over 2. So I'm actually going to just write that in place. And get rid of all of this. Okay. I don't need that either. Just saving space. Okay, great. So that means I've actually got that bit sorted. Last thing is to worry about the limits. Don't forget those. So x and u, we have our expression for u. So to find u, times x by 4 and then take away 1. Firstly, I've got 1/2 and then I've got, whoa, I don't know what happened there. My pen's gone a bit weird. There we go, it's come back. Apologies about that. So 1/2 and 1/4. So if I times by 4 first, that'll give me 2, and then take away 1 gives me 1. If I times 1/4 by 4, it gives me 1, and then take away 1 gives me 0. So there's my new limits. So I'm going to then write integral, 1/2's going to 1, and 1/4's going to 0. Not going to worry about those anymore. Then 5 minus 2x, I'm going to write as being 9 minus u over 2. And this, remember, is our u. So that will just be u to the 3rd. Putting in dx is just du over 4. So noticing I've got a 2 there and a 4 there. 2 times 4 is 8. So that will be bringing out 1/8. Left with 9 minus u times by u to the power of 1/3 du. So this will go to 1/8. We have 9 times u to the 1/2, so that's 9u to the 1/2. Sorry, 9u to the 3rd, I should have said, not half. And then we have minus u times u to the 3rd. That will be minus u to the power of 4/3, and then du. So we're not far off now. We've got 1/8 there. Sorry, I shouldn't write a curly one because we're actually evaluating the integral now, aren't we? So increase the power by 1 and then divide by the new power. That would be 4/3, and reciprocating that is 3/4. We've already got a 9 there, and then a 3/4 as well. Sorry, let me redo that. That's completely wrong. So we've got to increase the power by 1. There we go. And then divide by the new power, gives us 3/4, yeah? Brilliant. And then this one here, this power is going to go to 7/3. And then 3/7 is its reciprocal. Brilliant. So I'm just going to put this through now because I think it's easier. 3 times 9 is 27. 4. Then we've got u to the 4/3. Take away 3/7 u to the 7/3. Now it looks horrible in here, but remember you've only got 1 and 0 as limits. So 1 to the power of anything is just 1, and 0 to the power of anything is just 0. So this will be pretty simple, but I'll show you where I'm coming from. So if I put a 1 there, even with that power, it's still just 1. But I'm going to do it anyway, just to be complete. Because you should write your working anyway, even if you know it's going to simplify or just go to 0. Still good practice. Right, so like I was saying, that is just a 1. That is just a 1. That's 0, and that's 0. So all of that is going to be 0. So we only need to worry about the front one. So we have 27/4. Remember, it's times 1, so we'll just write that. Then we have minus 3/7, and that's just times 1. So I just write that. And then all of that at the back is 0. So we're here now. Actually, what I'm going to do, rather than leaving that there again, let's just times the 8 by the denominators here. So we have 27, 4 times by 8. Okay, and then we have minus 3, and then 7 times 8 being 56. All you would then do is obviously just compute that final part, and what you should find is it gives you 177/224. If you're unsure on that final bit, let's just go through it. So basically need to times this by 7. That'll give you 224 for that. And this one here, I believe you times it by 4. Yep. So that means times this one, that's times 4, that's times 4, that's 12. That's got to be times by, what did we say, was it 6? I can't remember. That's 7, sorry, 7 and 7. And that gives you 189. Subtract those, giving you 177/224. And that is it, your final answer. It's the best way to leave it. It's an exact of how you like that, okay? If you was to write it as a decimal, you would get something pretty horrible. Like that. So I would probably stick with the fraction, okay? Right, we'll leave it there for today. If any of this has helped you, please feel free to like and subscribe. It really supports me and the channel. It helps other people find me, and it helps the maths get out to everyone. I will be uploading a whole series of A-level videos, and at some point I'll be doing some GCSE videos as well, and I'll be going through even harder maths beyond A level. So if anyone's doing sort of degree level maths, or degree level physics, anything like that, I'll be going through some of the harder theorems within physics, engineering and mathematics. So really this channel is to support all of the STEM subjects. If anyone has any requests, or want to ask a particular question, or want me to go through certain topic or certain type of examples, exam questions, whatever, just drop me a comment or a message and I'll be happy to do that. Thank you, and I hope you have a lovely day.